What I put my effort toward currently as an engineer is a powered rope climbing device that's useful for search and rescue operations. It allows a person to much more quickly and easily execute high-angle rescue scenarios, such as what firefighters might perform. My name is Nate Ball, and I'm a mechanical engineer. My job as an engineer is to use what I know about the world and what I know about how things work to solve problems to help people.
As a mechanical engineer, Nate pushes technology to its limits by using his knowledge of motion and energy to develop all sorts of mechanical devices, including a new vaccine delivery system called the Vac Pack.
There are about 4.3 million deaths that are caused every year by vaccine-preventable diseases. And a major challenge in getting vaccines to the appropriate places in third world countries is being able to keep them at the right temperature. Vaccines have to stay, in general, at about 4 degrees Celsius in order to stay usable. And to get vaccines at that temperature into really rural areas with spotty electrical power is a big challenge. This device here is a portable vaccine refrigeration backpack. It's like a refrigerator you wear on your back that allows you to take up to 1,200 vaccine doses into a rural area that doesn't have normal power. So in a situation where you've got major infrastructure devastation, like in a huge earthquake in a third world country, a device like this has great potential to make a big difference because you can take massive doses of antibiotics and needed medicines into rural areas that have no power in order to be able to deliver the needed medical help.
Nate spends much of his time refining his designs and building models and prototypes to get products ready for manufacturing.
What we're looking at here is a 3D model of an early version of the backpack that's actually created inside the computer. So in engineering, if you're building a complicated system, it's very useful to build a model like this in order to visualize how all the parts will actually attach together. You guys need to...
Nate shares his passion for engineering by mentoring others. He even hosts a TV show for PBS called Design Squad.
So on the show, I get to mentor a couple of teams of young engineers and introduce challenges to them as week to week they split into teams and hear from a client, kind of like real engineers do. And the client says, hey, Design Squads, I need you to build this for me. I need you to solve this problem.
I want you to build me the fastest dragster possible.
And the kids on the show actually go out and do it.
All right, so we got our forks up in front.
We're gonna have a 6-foot coil of rebar like a tornado.
When he's not inspiring future engineers, Nate can often be found helping athletes reach new heights.
I actually coach some of the MIT pole vaulters here. And I'm also a pole vaulter myself, and I have been since about 6th grade. It's kind of cool because coming to pole vaulting from an engineering perspective as a coach, I get to describe physically what's going on in a different way that other pole vault coaches might do. This is where the box is. You want the bar to be back away from it so that when you peak, you're not going to fall back down into that steel encased in concrete. A neat thing about engineering is that it allows you to solve all kinds of problems, ranging from building cool things like dragsters and bridges and skyscrapers, to solving interesting, complicated problems like how do you get a drug directly into your skin without the use of a needle.
When a natural disaster or a fast-moving epidemic strikes, a needle-free injection device could save countless lives.
So a project that I've been working on is a controllable version of that needle-free drug transport. This device, instead of using a gas-powered piston to fire in, actually uses a controllable actuator. So you can dial down the power in real time to inject an elderly person or a child, and dial the power back up for a person with tough skin. The advantage of that is huge because you can imagine having a delivery gun that's got a very large vial of vaccine. You can line up a whole bunch of people and just put it up to each person's arm and shoot right down the line and inoculate a huge amount of people in a very short amount of time.
Nate's a busy guy, even during his downtime.
I guess the physicality of getting out and doing stuff with your body is a nice break from your brain, and being in some kind of shape physically kind of helps us work harder mentally during the on hours. We really enjoy getting out there and working hard and flipping upside down and sort of, I guess, applying some kind of physics understanding to what's actually happening in the air as we run and flip through the air off of obstacles and what have you. Engineering by no means is all fun and games either. it's never going to be a straight through process where you come in, see the problem, and think, oh, I know how to solve it right away. You may not even have consensus in your group as to how to solve the problem in the first place. And you're working with limited resources and limited time. So persistence is a very important aspect of being an engineer. I love solving problems, and I love that engineering is a creative job. There's a whole world of things to invent and create and work with people on, and so you're never bored as an engineer. A couple colleagues of mine who are also engineers are working on a pretty cool project that's called the Tourbot. And what that is a robot that's designed to rove around the halls of MIT giving tours.
Welcome to MIT.
While we're building a system that's giving tours of the MIT campus, we're not necessarily only trying to figure out how to build systems to give, tours. We're trying to see how you can get robots to interact with people, to really be able to serve people and interact and change people's lives.
Additionally, the navigation systems they put on the robot are pretty state-of-the-art.
We use a variety of sensors. We have laser range finders that we use to find obstacles around us. We have a camera that looks at the ceiling to read markers that we place there that kind of tell the robot where it is.
Those sensors could have implications for robots in other scenarios, like hospitals or work sites, or museums, libraries, who knows.
Hi, Patrick. I will be your friend today.
What I'm working on right here is a preliminary design for a robot arm that you could add to a robot similar to the Tourbot in order to make it do something like pick up an object off the ground or even open a door if you wanted to. So it's a multi-degree of freedom system, which means similar to the human arm, it's got a lot of different joints that can function in several different ways.
Nate also manages to find time to engineer some jazz improvisations.
It incorporates a lot of stuff I like about engineering in that you're kind of a free-flow process of coming up with new ideas, but it's in real time on the keyboard, and it's also a really relaxing outlet for me as well. Engineers can make a very good living, and the reason is the world always has important problems to solve, and the world will always need engineers. Things I love about engineering are that I get to work with other engineers that are passionate about solving problems and helping people. I get to see my work directly benefit people, and I always have a reason to keep learning and to keep applying my new knowledge to new interesting problems to solve. In 10 years or 20 years or at the end of my life, I'd love to be able to look back and say, I've spent that time making people's lives better. That's what I want to do.